Hello, fourth year. In this video, we are going to be using Pythagoras' theorem to find one of the two shorter sides of a triangle, of a right angle triangle. So far we've used Pythagoras' theorem to find the hypotenuse, all right? We're now going to use it to find one of the two shorter sides of the triangle. The good news here is that we start off the question in exactly the same way as we did before. So draw your sketch and label your sketch, all right? Now I am using a couple of the questions that are on your worksheet. I would suggest you still do the questions on your own and then just check to see that your answers match mine. I'm labeling this up. Remember, I've said before that the hypotenuse, HYP, is the most important one to get right, okay? That's always opposite the right angle. The other two sides we call side A and side B. You can switch those around, okay? You can call X side B and 12 side A if you really want to. I'm sticking with it the way it is. Once we've done our sketch, once we've labelled it correctly, we write down Pythagoras' theorem, which says hypotenuse squared is equal to a squared plus b squared. Okay, for those of you that don't like writing, I know you don't want to write out formulas and things. This is really important, all right? I've said this before. Two reasons. One, it shows to the marker or somebody who's assessing you that you understand Pythagoras' theorem, or that you recognise the question uses Pythagoras' theorem. That could be enough to trigger a mark in a test. The other thing is it helps you to remember Pythagoras' theorem and store that away, which is really, really important. Okay. If it makes you feel any better, when I was at school, which you might argue is a long time ago, possibly it is, we had to write down by Pythagoras, then write Pythagoras' theorem, then solve the equation. So you're actually writing less than we did. I was going to say back in the day, but that's probably not cool. Once you've written out Pythagoras' theorem, pop in the numbers. So 13 squared is equal to x squared plus 12 squared. Okay, so that's just the information from my sketch. Notice that A is represented by x. We don't have a numerical value for that yet. I know that 13 squared is 169, and I know that 12 squared is 144. Okay, now what I have here is an equation. Okay, and it's an equation that I need to solve in order to find x. Before I do that, what I'm going to do is I'm just going to write it round the other way. Okay, so I'm just going to write it so that the 169 is on the right hand side and the x squared plus the 144 is on the left hand side. There's no difference. These two statements, these two lines here, are exactly the same. Okay, I haven't changed anything about them. All I've done is write them in a way that I think you will find a bit more normal. It's how you've seen them before, so you'll probably find it a bit more user-friendly to have them that way. Okay. I want to deal with this plus 144. I want that on the other side. All right. I want rid of it, don't I? So I'm going to take 144 away here. Subtract that, and that's going to leave x squared is equal, what's 169 take away 144? 25, correct. X therefore becomes the square root of 25, okay? To find the opposite or the inverse operation of squaring is the square root, so that would be 5 centimeters there, all right? And that's us done, okay? So there definitely are more steps involved in this, okay? But shouldn't be too tricky, hopefully. Let's have a look at this next example, and we'll start by labeling up our sketch. So sketch done, label, hypotenuse. I'm going to stick with A, and I'm going to stick with B. Okay, you'll notice how I'm making A squared my unknown. You might want to stick with that as well. Pythagoras' theorem, same as always, A squared plus B squared. Pop in the numbers, 8 squared equals, that's going to be x squared, isn't it? Yes, because A is x down here. So that's going to be x squared plus, and B is 5 squared. 8 squared I know is 64. 5 squared is 25. Now again, at this point, what I'm going to do is I'm going to write my equation around the other way. Okay, not changed anything, I've just flipped it from left to right. Okay, next thing to do, take away the 25. All right, I want to subtract 25 from both sides of that equation there. That would be x squared is equal to 64 minus 25, that's going to be 59. Take away 20, that's going to be 39. All right, now the last thing we do, the inverse operation of squaring, is to take the square root. So we're going to do x is equal to the square root of 39. Now, that doesn't have a nice answer. It's going to be 6.244 and then lots of numbers. So I'm going to round that. I'm going to make that 6.2, and that's a 1 decimal place answer. Okay, quite common to have to round when you're doing Pythagoras. Not always, but it is quite a common thing to have happen. So we're saying there that side A is 6.2 centimeters in this example. All right, two quick example, couple of extra steps in there. All right, you have to create an equation and then solve the equation, but hopefully that's not too tricky for you. Remember, you can access these solutions as they are right now by going into your class notebook, which is a link to at the top, and then into your content library, which is here, and then all the way down to Pythagoras Theorem at the bottom, and then it's actually the second page, and you'll be able to see these. Okay, so you've got access to these solutions all the time, not just through the video. All right, while you're watching the video, stop it. All right, if you're not sure, you don't have to watch it all at once, just pause it, make sure you understand what's going on, then carry on. If you lose the thread, if you're not sure what exactly it is I've done, then if you want to send me the time on the video where you kind of stop understanding, that would be a really useful way to let me know exactly where you need help. All right, so that's specific information. It's much more useful than a kind of general inquiry. All right, I will be online on Friday to help you with this if you want assistance. Obviously, you can send questions outside of that time, and I will try and get back to you as soon as I can. I hope the video is useful, and I hope the work is accessible for you.